Next would be linear equations involving absolute value. But still, we are still considering here first the one variable. So linear equations in one variable involving absolute value. Take note, guys, that absolute value of x is equivalent to square root of x squared, which is x if x is greater than or equal to 0, and negative x if x is less than 0. It means that the absolute value of negative 1 is 1, and the absolute value of 1 is 1. So an absolute value is something that gives a quantity positive value. Okay, if it's a negative, if it's a positive, then the absolute value of it is still positive. Okay, so now if we have 2x plus 1, the absolute value of 2x plus 1, this can be written as 2x plus 1 if 2x plus 1 is greater than or equal to 0, and negative 2x plus 1 if 2x plus 1 is less than 0. In this case, this 2x plus 1 can even be simplified as x greater than or equal to negative 1/2, and in the other case we have x is less than negative 1/2. Okay, now let's take some important rules in dealing with absolute value. Okay, let's call it important rules. This will be our guide in solving linear equations involving absolute value. One is, for p greater than 0, the absolute value of x equals p is equivalent to x equals p or x equals negative p. So if we have, say, absolute value of x equals 2, this is equivalent to x equals 2 or x equals negative 2. So your solution here is plus minus 2. Okay, another example. What is the absolute value of x equals negative 5? Now, as what we have mentioned a while ago, the absolute value will give something a positive 1. And since the absolute value is equated to negative 5, this means it has no solution. Okay, it has no solution because, again, absolute value always result to something positive. Now, assuming we forget that concept and we still want to apply this rule here, okay, just assuming, let's try to check if it has no solution really. So absolute value of x, let's try solving it, equals negative 5, and then we have x is equal to negative 5 or x equals 5. Okay, negative 5. Now let's try to check here, meaning we have a possibility of negative 5. So if x is negative 5, if x is negative 5, then we have, is negative 5 equivalent to negative 5? Negative 5 is 5, which is not equivalent to negative 5. So negative 5 is not a solution. Then for 5, if x is 5, we have 5, is it equivalent to negative 5? 5 is not equivalent to negative 5. So 5 is not a solution either. So therefore, if x, the absolute value of x equals 5, equals negative 5, has no solution. Or any absolute value equated to a negative number, it must have no solution. Okay, I hope we are clear on that. Next, for p greater than 0, the absolute value of ax plus b equals p is equivalent to ax plus b equals p, or ax plus b equals negative p. Okay, example, what is the absolute value of 3x minus 1 equated to 2? Okay, from our rule, we have the absolute value of 3x minus 1 equals 2 is equivalent to 3x minus 1 equals 2, or 3x minus 1 equals negative 2. Then you can simplify this one by applying the addition property of equality, then multiplication property of equality. We have 3x equals 2 plus 1. Then we have 3x equals 3 divided by 3, x equals 1. On the other hand, we have 3x equals negative 2 plus 1. 3x equals negative 1 divided by 3, x is equal to negative 1/3. So therefore, our solution set for this is negative 1/3 and 1. Okay, let's have another example. Solve the absolute value of 5x plus 1 minus 3 equals 0. So guys, here you have to be very careful, because you cannot apply the rule directly like 5x plus 1 minus 3 equals 0, or 5x plus 1 minus 3 equals negative 0. Okay, you cannot apply this one first. Why? Because the negative 3 here is not part of your absolute value. Okay, so you have to set this first as absolute value of an expression equals p, where p is positive, because that's our rule. So here, write the problem first. 5x plus 1 minus 3 equals 0, which is equivalent to applying the addition property of equality to eliminate negative 3 on the left side. We have absolute value of 5x plus 1 is equal to 3. In this case, the left side is absolute value. Everything is inside the absolute value. And the right side is a constant, which is our p. So now, we can apply our rule, which is 5x plus 1 equals 3, or 5x plus 1 equals negative 3. Then we can simplify this one to find the value of x by again applying the addition property of equality and the multiplication property of equality. So we have 5x equals 3 minus 1. 5x equals 2 divided by 5 divided by 5. X is equal to 2 over 5. Or on the other side, we have 5x equals negative 3 minus 1. 5x equals negative 4 divided by 5. X is equal to negative 4 over 5. So therefore, your solution set would be negative 4 over 5 and then 25. Okay. Next example, we have absolute value of 2x plus 3 plus 5 equals 0. Again, we cannot apply first the rule if there is still a term on same side of the absolute value which is not part of the absolute value. Example, the 5 here is not part of the absolute value. So we will eliminate the 5 on the left side by again applying the addition property of equality. So we have 2x plus 3 plus 5 equals 0 is equivalent to absolute value of 2x plus 3 equals negative 5. But again, absolute value here is equated to a negative number. As what I mentioned a while ago, absolute value always result to something positive. So therefore, since this is negative, then we don't have solution for that. So this is no solution. Or we can write this one in a solution set as open braces, or the solution set, the empty notation, which is the empty notation. Okay, another example. 3 times x minus 3 plus 2 equals 2x plus 1. So in this case, guys, we have plus 2 outside of the absolute value and 3 outside of the absolute value. So we will transfer that one on the other side by again applying the addition property of equality and the multiplication property of equality. So we have 3 absolute value of x minus 3 plus 2 equals 2x plus 1. Addition property of equality first. We have x minus 3 equals 2x plus 1 minus 2 is minus 1. And then divided by 3 on both sides of the equation, we have absolute value of x minus 3 equals 2x minus 1 over 3. So here, we can apply now the absolute value expression or rule. So we have, this is equivalent to x minus 3 equals 2x minus 1 over 3, or x minus 3 equals the negative of 2x minus 1 over 3. Then simplify one by one. We have, so we can multiply 3 on both sides here to eliminate the fraction. So we have 3x minus 9 equals 2x minus 1. Combine the variables on the left side and combine the constants on the right side. So we have 3x minus 2x equals minus 1 plus 9. So x is equal to 8. Now in this other side is we have x minus 3 equals, distribute the negative first. So we have negative 2x plus 1 over 3. Then multiplying 3 on both sides of the equation to eliminate the denominator, we have 3x minus 9 equals negative 2x plus 1. Then combining the variable on the left side, we have 3x plus 2x equals 1 plus 9. So this is 5x equals 10. Divided by 5 on both sides, we have x equals 2. Now, here, just a little warning. You cannot just write directly the solution set as 2 and 8. You have to substitute it first to the original problem if the equation is correct. Okay? Now, the idea here, if there is a variable outside the absolute value, you have to substitute first whatever answer, whatever value of x that would come up in your solution before putting it in a solution set, because it might not be a solution or it might be a solution. So here, since we have x equals 8 and x equals 2, let's substitute first on our original problem. So for 8 first, 3 times, okay, let's have it as checking. Okay, 3 times 8 minus absolute value of 8 minus 3 plus 2, is it equal to 2 times 8 plus 1? So we have 3, absolute value of 8 minus 3 is 5, plus 2 equals, this is 16 plus 1. So that is 3 times 5 plus 2, is it equivalent to 17? 3 times 5 is 15, plus 2, 17 equals 17. So 8 is a solution. How about 2? So we have 3 times 2 minus 3 plus 2, is it equivalent to 2 times 2 plus 1? So that's 2, absolute value of negative 1 plus 2 is equal to, or is it really equal to 4 plus 1? Again, the absolute value of negative 1 is positive 1 plus 2, is it equivalent to 5? 5 is equivalent to 5. So therefore, both 2 and 8 are solutions to the equation. So we have the solution set is 2 and 8. Okay. Let's have 2 examples before we proceed to our next topic. Last 2 examples. How about this one? Absolute value of 4 minus 5x minus 3x plus 2 equals 0. So we have simplify that one first. So we have 4 minus 5x minus 3x plus 2 equals 0 is just equivalent to absolute value of 4 minus 5x equals 3x minus 2 after applying the addition property of equality. Then we have 4 minus 5x equals 3x minus 2, or 4 minus 5x equals negative 3x minus 2. Then simplify this one. Minus 5x minus 3x equals negative 2 minus 4. We have negative 8x equals negative 6 divided by negative 8 on both sides. We have x is equal to 6 over 8, that's 3 over 4. Then here we have 4 minus 5x equals negative 3x plus 2, negative 5x plus 3x equals 2 minus 4, then negative 2x equals negative 2 divided by negative 2 on both sides. We have x equals 1. Again, before making it as your solution set, let's substitute it first to our original problem. So first on the 3/4 checking, we have 4 minus 5 times 3 over 4 absolute value minus 3x plus 2, is it equivalent to 0? So this is 4 minus 15 over 4 minus, this is 3/4, sorry. Then that is 9 over 4 plus 2, is it equivalent to 0? Then we have the fraction for that. 4 times 4 is 16 minus 15 minus 9 plus 8 over 4, is it equivalent to 0? This is 1/4 absolute value minus 1/4 equals 0. So 1/4 minus 1/4 is 0. 0 equals 0. So therefore 3/4 is a solution. How about 1? So we have 4 minus 5 times 1 minus 3 times 1 plus 2, is it equivalent to 0? So that's 4 minus 5 minus 3 plus 2. So this is negative 1 minus 1. So that is 1 minus 1 is 0. So 0 equals 0. So therefore 1 is also a solution. So both 3/4 and 1 are solutions. So the solution set is 3/4 and 1. Okay. Last example, guys. We have tried to solve this one. 4 minus 3x equals 2x minus 11. So in this case, we can apply directly the rule since the left side is everything, and the left side is inside the absolute value. So we have 4 minus 3x equals 2x minus 11, which is equivalent to 4 minus 3x equals 2x minus 11, or 4 minus 3x equals negative 2x minus 11. So we have minus 3x minus 2x equals negative 11 minus 4. That's negative 5x equals negative 15 divided by negative 5 on both sides. X is equal to 3. Or on the other side, we have 4 minus 3x equals negative 2x plus 11, combining the variables again, plus 2x equals 11 minus 4. So that's negative x equals 11 minus 4, that's 8. No, that's 7. So negative 1, x is equal to negative 7. So substitute first if that is really a solution. So checking, we have absolute value of 4 minus 3 times 3 equals 2 times 3 minus 11. So that means 4 minus 9, is it equivalent to 6 minus 11? 4 minus 9 is negative 5. 6 minus 11 is negative 5. But the absolute value of negative 5 is 5, equated to negative 5, then they are not equal. So x here is not a solution. How about the negative 7? 4 minus 3 times negative 7, absolute value equals, is it equal to 2 times negative 7 minus 11? So we have 4 minus, so that becomes plus 21. Is it equivalent to negative 14 minus 11? 4 plus 21, that's absolute value of 25. This is negative 25. 25 is not equal to negative 25. So negative 7 is not a solution. So this is what I mean a while ago, guys. If there is a variable outside the absolute value, try to check first your answer if that's really a solution. So in this case, it happened that although we came up with x equals 3 and x equals negative 7, both are not solutions after checking the equation. So therefore here, the solution set is empty. Okay, meaning we don't have a solution for the equation. We cannot find a real number that would satisfy the absolute value equation. Question? Okay, that's right.